In Lesson 8.3, you'll learn about scientific notation. You'll learn how to express numbers in scientific notation and standard notation, and to find products and quotients of numbers expressed in scientific notation. Why is scientific notation important in astronomy? Astronomers often work with very large numbers, such as the masses of planets. The mass of each planet in our solar system is given in the table. Notice that each value is written as a product of a number and a power of 10. These values are written in scientific notation. A number is expressed in scientific notation when it is written as a product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. In other words, one digit. A number in scientific notation is written as a times 10 to the n, where a is between 1 and 10 and n is an integer. 1.23 times 10 to the fourth is written in scientific notation. If we wanted to move it back to standard notation, 10 to the fourth would be the same as 10,000, 4 zeros there. And when we multiply by a power of 10, we always move our decimal 4 places to the right. So I'm going to move it 1, 2 to get to the end of the 3. Then I have to go 2 more. So that would be 1, 2, 3, and then I needed 2 zeros. So it would be 123,000. If we have a negative exponent, our exponent is going to move the decimal instead of moving it to the right, making our number bigger. Our exponent is going to move our decimal this time to the left. So I had 10 to the fourth, I moved it 4 places. 10 to the eighth, I'm going to move it 8 places. So 1 place gets me in front of the 5, and then I'm going to have to do 7 more. Run out of room. Okay, so the idea is it's getting smaller. So I'm going to have 7 zeros. Well, 1 0 in front of my decimal, but 7 zeros. 4, 5, 6, 7. And now you can see why scientific notation is used, because that's only times 10 to the negative 8th, and that looks like a mess. If we had something like in the table where they had 1.27 times 10 to the 22nd, that would be a lot of zeros and very difficult to understand in standard notation. Okay, the first step to put a number into standard notation, I think is kind of funny. Determine whether n is greater than or less than 0. Aha. So in other words, are we working with a big or a small number? If it's a big number, we're going to move the decimal place 8 places to the right. And if n is a small number, we're going to move the decimal place in a n places to the left. Okay, so add zeros, decimal point, and or commas as needed to indicate place value. Okay, commas are good for big numbers. Unfortunately, we don't use them for small numbers. So this is 10 to the negative third, so that is going to be a small number. So I'm going to have to move my decimal 3 places to the left here, and we're going from scientific to standard. So that means I need 2 zeros in front of my 7. And that's an ugly 8, but that's our answer, 0.00748. Now this is what you've seen in earlier classes. The 5 is a large number, so we're going to move our decimal to the right. Okay, so 2 places gets me after the 9, and I still have 3 more to go. So it's going to be 219, and then I need 3 zeros. And to read it, it's nice to put the comma in there, so it's 219,000. Now we're going to look at how to move the other way, from standard to scientific notation. We're going to move the decimal point so it is to the right of the first non-zero digit. This will result as a decimal number A. Observe the number of places n and the direction in which you move the decimal point. If the decimal point was moved to the left, write it as a to the times 10 to the n. If it was moved to the right, then we're going to write it as a times 10 to the negative n. So this is a large number, and this is a small number. That's helpful for me. So we always want to start off with exactly one digit in front of the decimal. So I know I'm going to have 6.72 times 10 to the, this is a small number, so it's going to be negative. And now the fun part, I need to count all these. So we had to move our decimal 1, 2, 3, 4, 5, 6, 7 places. So negative 7. Okay, that would be 1,000, million, billion, trillion. So we have 3,022,000,000,000,000. So at first I always need to start with one digit in front of the decimal. So I'm going to have 3.022 times 10 to the, and it's definitely a large number. So I'm going to count how many places I had to move my decimal here, and I'm going to move it 1, 2, 3, 4, 5, 6. So the commas are helpful. 7, 8, 9, 10, 11, 12 places. Okay, so you can kind of see what I would normally do. I would count those commas and just go, hey, I've got 1, 2, 3, 4 sets of 3, so 4 times 3 is 12, and you're done. The Sporting Goods Manufacturers Association reported that in 2000, women spent $4.4 billion on 124 million pairs of shoes. Men spent $8.3 billion on 169 million pairs of shoes. Express the numbers of pairs of shoes sold to women, pairs to men, and total by both in men and women in standard notation. Okay, so for women we have 124 million. There are 6 zeros in a million, so that would be 124, 2, 3, 4, 5, 6. For men was 169 million. So that's going to be 169 with 6 zeros after it. And the commas again help us read it, so that's nice. And then we need our total. That gets us to do 2 more numbers in standard form. So, and the nice thing here is I need 9 zeros. So my decimal there just became a comma, so that worked out well. So zeros, I need 9 place moves. That first digit there is not a 0. But it's going to be easy to add. 0 plus 0 is 0. Who knew? Okay, so finally I get a 7. Make it a little European there. Okay, so I end up with $12,700,000,000. And finally, they want us to write each of these numbers in scientific notation, which is nice with the commas. For women, I'm going to have 1.24 times 10 to the, let's count real quick, there's 3, 6, 7, 8. For men, it's going to be the same thing, 1.69 times 10 to the 8th. And for the total, 1.27 times 10 to the, let's count here, there's 3, 6, 9, and one more is 10. Okay, time to sit up straight. We're doing something new. We're going to evaluate the product of 2 numbers written in scientific notation. This is very useful. So the first thing I'd like to do is use our commutative property and rearrange things. So I'm going to have 7 times 4.3 times 10 to the negative 6 times 10 to the 12th. So I just grouped the numbers out front that are not in exponential form, and I grouped the things that were in exponential form. So then we can multiply real quickly. 7 times 4.3 is 30.1. And power times a power, we add exponents, so it's times 10 to the negative 6 plus 12 is 6. Okay, now 30.1, that's not what we want this to look like. In scientific notation, we should always have one digit in front of the decimal. So I'm going to rewrite that as 3.01 times 10 to the 1, moving my decimal one place to the left. And then we still have times 10 to the 6th. Power times a power, we add exponents, so our final answer is going to be 3.01 times 10 to the 7th. Oh, but wait, that's in scientific notation, and they want it in standard form as well. I tend to forget that part because I have one answer. Okay, so now moving it to standard form, 3.301. Okay, so I moved my decimal 2 places to get after the 1, and I need 5 more zeros. Nice thing about recording is I can catch these things that I usually miss live. Okay, division is going to look very similar. Again, I'm going to group the things, the like things together. There's my not exponent part, and then here is my exponent part. Okay, and when I divide, oh, that's lovely. That comes out perfectly. 64 divided by 16 is exactly 4. If I move both my decimals, I could do that in my head. And then power divided by power, we subtract exponents, so it would be times 10 to the negative third. Can I fix that? Yes, I can. I was looking at my 7 going, oh, that's an ugly 7. Okay, but we also need it in standard form, so that's going to be the same as move our decimal 3 places, so it's going to be 0.003. And the 0 in front is not mathematically significant, this 0. That's about our eyeball seeing the decimal point. So if you do not write that 0, it is okay, but you will see that every place it's typed because it helps our eye see the decimal. A number is expressed in scientific notation when it is written as a product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. In other words, when a number is in scientific notation, no more than one digit is to the left of the decimal point. In fact, it's exactly 1.